Welcome to the session on step count method for determining algorithm complexity. We assume that you have understood the prerequisite topics, namely algorithm properties, algorithm patterns, control structures, analysis of algorithm. This will help you in better understanding of this topic. In this session, we will discuss a method known as step count to determine time complexity of an algorithm. As we have discussed that time complexity of an algorithm is the time required to execute. How much time the algorithm execution will take is dependent on the number of steps in the algorithm. The number of steps depends on the size of the problem, so the complexity is a function of problem size, and this function helps us in determining order of complexity of an algorithm called as order of magnitude. In order to use number of steps for determining order of magnitude and comparing algorithms, we need to understand what is step in an algorithm and how to count it. How to convert the number of steps into order of magnitude, and how to decide which algorithm is better using order of magnitude. Let us understand what is a step in an algorithm. Each operation in an algorithm can be considered as a step. It includes mathematical operations, logical operation, conditional operation, function calls, assignment operation, and array reference. Please pause the video and observe how step count is determined for various statements. Let us discuss few more important aspects related to step count. Step count is generally calculated in terms of problem size and used to derive algorithm complexity in terms of order of magnitude. As discussed earlier, we are usually interested to analyze worst case scenario, so steps are counted in worst case scenario, and that provides us the worst case complexity of an algorithm. Let us look at some algorithm examples to understand step count method. Here we have a method called sum, which accepts an array of integers called array and a number n and returns the sum of the numbers stored in the array. Let us count number of steps in the algorithm. Line 1.1. Tsum is equal to 0 contains one step, that is assignment operation. Line 1.2. For I equal to 0, I less than n, I equal to I plus 1 contains one assignment, that is I is equal to 0 and n plus 1 comparisons, and 2n steps in I equal to I plus 1, so total steps will be 3n plus 2. Line 1.2.1. executes n times, and each time it executes 3 steps, namely assignment, addition, and array reference. So total number of steps are 3n. Line 1.3 contains a return statement which executes only once. If we add all these steps, it will be 6n plus 4. Let us look at step count calculation for a recursive function fact, which is calculating factorial of a number n. The line 1.1 contains a condition which is evaluated n times. Line 1.2 contains a return statement which executes only once. Line 1.2.1 contains 4 steps, 1 subtraction, 1 function call, 1 multiplication, and 1 return, and these are executed n minus 1 time. So total step in this line is 4 into n minus 1, that is 4n minus 4. If we sum up steps, step count for the algorithm is 5n minus 3. Let us now discuss how the step count calculated for an algorithm is used to derive order of magnitude. As we are calculating the steps, considering the worst case scenario, the order of magnitude which we will get with this step count is represented by big O notation. In order to calculate order of magnitude from the step count, we need to follow certain assumptions. The first assumption is ignore low order terms and multiplicative constant of highest order term from step count. For example, if step count is 10n cube plus 3n square plus 5, after ignoring lower order terms 3n square plus 5 and ignoring multiplicative of n cube, that is 10, order of magnitude will be n cube. Second assumption says that we can simplify calculation of step count for a loop in place of calculating each step independently. We can consider number of statements within the loop multiplied by number of iterations as step count. For example, in the given code, we have 3 statements inside a for loop, and the loop executes for n times, so the step count for this loop is 3n. And after applying first assumption, the order of magnitude is n. Third assumption provides a way to calculate step count in nested loop. In case of nested loops, the analysis starts from the innermost loop and moves towards outer loop. Like in given example, by applying assumption 2, inner loop's step count is 3n and the outer loop executes m times, so the total steps are m multiplied by 3n. Considering m and n are large values and m close to n, we can say step count is 3n square, and after applying assumption 1, the order of magnitude is n square. Assumption 4 gives us way of calculating step counts in if-else statement. As we are calculating step count in worst case scenario, we consider the step count of either if or the else part, whichever is more, plus the count of if condition. As in the given code, step count in if part is 1 and else part is n. The step count for if condition is 1. So we calculate the total step count as step count of if condition, that is 1 plus maximum of step counts of if and else parts, that is maximum of 1 and n. Hence, after applying assumption 1, the order of magnitude is n. After determining order of magnitude of all feasible algorithms available for solving a problem, the task is to determine the best one. The algorithm with minimum order of magnitude is considered as the best for implementation. The given graph shows how the execution time increases based on order of magnitude, and it is clearly evident that order of one algorithm is the best one, if available, and order of n to the power n algorithms are worst. So for example, if we have choice between big O n log n algorithm and big O n square algorithm, and the problem size is large, we should select big O n log n algorithm, as it will take less amount of time as compared to big O n square algorithm. Let us summarize our learning. Step count method is used for determining complexity of an algorithm in terms of order of magnitude. Steps are counted in worst case scenario in order to determine worst case complexity.